This is a variable transformation problem where we're given the number of cars in North America and the number of cars in China. We want to convert those to profits in those respective areas. Before we get started though, we're given variance. So sx squared and sy squared. We sometimes prefer working with standard deviation. So I'm going to go ahead and take the square root of both of these numbers to go ahead and get standard deviation. So that means sx is 90 and sy, the standard deviation of y, is 80. Okay, now that I have that, I want to create equations that relate profits, or rather the number of cars, to the profits in North America. So starting with North America, we're told that we get $2.1 thousand per car, and since X is the number of cars we sell in North America, then our total revenue from selling cars in North America will be 2.1 times X. So let's start with PRX. That'll be 2.1X, and then don't forget we have costs. So those costs are negative 176, or rather those costs come out of our profits, so that's why we subtract. Let's do the same thing for China. We have PRY, profits in China. That would be $1.2 thousand per car there, but we have costs of 23,000. Okay, now that we have equations, we're going to use these formulas to relate the mean of X to the profits, or the mean profits of X. So here's how we're going to do that. Notice that this equation has bar over Z and has a bar over X. That's the exact same thing we're going to do here. We're going to put a bar over our PRX, and we're going to put a bar over our X bar. Not much has changed. All we did was put a bar over PRX and a bar over X. Okay, we want the mean of the profits in North America, but we have the mean of the number of cars. So we'll just take the mean of the number of cars, which was namely 12100, and plug it in here. 2.1 times 12100 minus 176 equals 25234. Okay, we're going to do the same thing for China. We have PRY bar equals 1.2 times Y bar minus 23, which if we plug in Y bar, which is 7500, we get 1.2 times 7500 minus 23, which comes out to be 8977. All right, that's the mean. Those are how you handle the mean. But now we're going to use this equation to help us handle standard deviation. So standard deviation of profits in North America equals B times SX. Now B just represents the coefficient of X up here. So in this case, B is 2.1. We'll have 2.1 times SX. And in this case, SX is 90. So we have 2.1 times 90. This comes out to be 189. The next part wants the variance for the profit in China. So that wants S squared PRY. We're going to start with PRY, SPRY. There's the profits in China, the standard deviation. We're going to do it the same way we did before. Instead of 2.1, the formula for China's profits are 1.2 times SY. And in this case, SY is 80. So we have 1.2 times 80 equals 96. Now be careful, this is merely the standard deviation of profits, but we want the variance. So in order to get the variance of profits, we need to square this number. So if I take 96 and I square it, I get 9216. Okay, lastly, we have to go ahead and wrap up with covariance. This is the last formula we're going to use for covariance. The covariance of the two profits, so we'll say S, PRX, and PRY, equals B times D times S sub XY. S sub XY is the covariance given way back over here. So our covariance is 50/40. Let's put that here. B and D, however, represent the coefficients of X and Y in the equations of the profit. So this is B and this is D. I couldn't use the same variable B because then it would be confusing. Which B am I referring to? So B in this case refers to the coefficient of X, and D here refers to the coefficient of Y. So that'd be 2.1 and 1.2. Multiplying this all out gives me 12700.8.